Hello, ladies and gentlemen, boys and girls. This is Nasima, and you are watching GetWays Solution. In this video, I'll solve a lead code question again. So, without any further delay, let's get started. The question is valid. Parenthesis. This is an easy question. You should do it by yourself. But if you come here, means you need a basic intuition, like how you will reach toward the stack solution. So, I will cover the solution in detail, and I will tell you that the intuition behind, like why I came to that particular data structure, why I came to a conclusion that I have to use stack here, and why I how I come to the solution. So I will tell you the basic intuition also how we are reaching or where we are reaching. So yeah. So with that background in mind, let's get started. So question goes like this: valid parenthesis given a string as containing just the character this, and this. Determine if the input string is valid. So the rule for valid is that open bracket must be closed by the same type of bracket. So suppose we have this open bracket, so we need this bracket to be closed. Suppose we have parentheses, we need to be closed in this way. So like we need to have same closing parentheses. Open bracket must close in the correct order, so it should be in correct order, and every closed bracket has corresponding open bracket of the same type. So let's understand the rule. So first rule, what it is saying, that open bracket must be closed by same type of closed bracket. So suppose we have this is the open bracket, it should be closed by this only. This is valid and this is not valid. Similarly, this is not valid. So these two are not valid. So this is the first thing. This is the first case which we got. And now we'll go with the other. Open bracket must be closed in correct order. So suppose we have open bracket like this. First we have this, and then we have this, and then we have this, and then we have this. So if we see here, we have same number of this bracket, and we have same number of this bracket also. So in that case, we might think that this is correct, but according to our rule number 2, open bracket must be closed in correct order. So if we find this particular bracket, we need to have closed by this bracket only, not the other kind of closed bracket. So it should be in order. So this is invalid. Valid scenario for this will be, suppose we have this, and we have this, and we have this, and we have this. Now this is correct. So this is our rule number 2. Every closed bracket has corresponding open bracket of same type. We have condition like this. We found to be here, 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 here. So if we see here, this two bracket has been closed, this two will be closed, this two will be closed, but we have one remaining bracket. So every closed bracket has corresponding open bracket of the same type. So this particular closed open bracket didn't have any closed bracket. Suppose we have this also, and after that this also. So these two will get cancelled out, but we will remain with one closing bracket for which we didn't have any open bracket. So it breaks the rule number 3. So this is not a valid scenario. Hopefully you understand the question by now. So if we see, like how to solve it, how to, first of all, like we understood the question. Now if you think about solving it, I will remove all this. So now let's think about solving it. So how we will reach toward the solution. Let's make it red. Why I changed it? Okay. So now suppose here we have an example. We have this bracket, this bracket. So now in our example, suppose we are here, and when we reach to this point, okay, so we start iterating through, this is the string given, and we started iterating through the string. So when we are first position, we have seen an open bracket. So when we see an open bracket, what decision we need to take? Like, do we have anything in mind? So right now I am not getting anything in mind. Like when we see an open bracket, do we have to process anything? Do we have to do anything? No, but we need to store it, since because when we see a closing bracket, we might want to do something, so this is the open bracket. So what we will do, I will create one data structure. In that I will store it. This is the open bracket I have seen earlier. So this is the data structure. Now we don't know that this data structure is what. Is it a linked list? Is it a array list? Or is it a map? Or is it can't be map? See, map has key and value both. So is it a set or whatever? Is it a stack? So we'll see that. So now when we see a closing bracket, and this is the time. When we want to do something. We want to have a track of right before element. Right before element is what? So in data structure, we want, when we see a close bracket, we want to see what is the right before element. If it is a right before element, the previous element is the closing bracket of corresponding opening bracket. The previous element is opening bracket of corresponding closing bracket. If you see here, this is a closing bracket, and we want to look in a previous element. We want to look to a previous element and determine if previous element is this. If it is this, then it's okay. If it is not, then return false. So here we conclude that we want to look into the previous element. Always want to look into the previous element. So that, for that case, like we want to keep track of the open bracket, and we want to access the previous element, access the most recent element. How you will access the most recent element? That is the thing. Like suppose we have some element, we are putting some element like element 1, 2 and 3. The most recent element is 3, of course, so we want to access 3. So which kind of data structure is this? Like we want like latest element at first, so at top where we see top. So that is the case of stack. What is stack? First in last out, means last in, you can say in reverse also, last in first out. So whatever we see in last, that is the first. So we need some kind of data structure which hold last in first out. So that is the thing. So in our stack we have right now, as soon as we see open bracket, we use a data structure. That data structure is stack. In our stack we have these elements. And now one thing we have concluded, that we are going to store all opening bracket in stack. Hopefully you have followed it. Now another thing is that after seeing closing bracket, we have to find its pair. We have to find it the corresponding opening bracket. For every closing bracket we want to, for this we want to find this, for this we want to find this, and for this we want to find this. So we, with this we can conclude that we need some kind of key value. And where key value comes, suppose here we have this is the key, and for that value is this. So we need some kind of data structure which is key value pair data structure. So with that thing in mind, we can say that we need to use map, and we'll use hash map here. So in that this will be the key. So I will use eraser here. Okay. This is weird. So I'll use, this is key and this is value. Hopefully it's visible. So now we have key and value. Now we will go with the our iteration. So as soon as we see open bracket, we will store it in stack, and as soon as we find closing bracket, we will pop it from the stack. Now our stack is empty. Now again, as soon as we see open bracket, we will store it in a stack, and as soon as we see a closing bracket, we will look for it in a map, and as soon as again we will pop it, and similarly we go ahead. Suppose at last of this element, this is the example which will return true. Suppose at last of this element we have this. So in that case, we will store this element in stack. But when we go ahead, we already iterate through the whole string. So at last we have to check, like if stack is empty. So in our case, stack is not empty. So if stack is not empty, means we have a value which is, we have a opening bracket for which we didn't find a corresponding closing bracket. So that is the case. That is one case we have to keep in mind. So that is one case we have to keep in mind. So now I will write a pseudo code, or I will directly jump in code, and let's see. Hopefully you build the intuition, and if there's any issue, I will explain the code again, and while coding I will explain everything. So hopefully while coding you will understand everything. So no problem. So the intention behind explaining the solution earlier is to just have understanding how we are going to use data structure. So first and most important thing, we are going to use map. So let's declare a map of character, and let's call it as hash map and new hash map. So if you are using C++, then also syntax will be similar. You can understand, like if you know your C++, you can understand like what I'm doing here. So it's just a little bit difference in syntax. So here we have used a hash map. In hash map we need for all closing bracket we need corresponding opening bracket, as we have discussed earlier. I should not have removed this. I don't know how to. Okay, I'll try to come. Yeah. So we have decided in hash map for all closing bracket we need a corresponding opening bracket. So in map I'm going to put, this is the key and this is the value, and go. Similarly I'll take this, so for this, so basically I'm putting all the corresponding values as we have discussed earlier. So now in our map we have all the field which we need. So we have all the corresponding closing and opening bracket. So before this step is the first step. Let's say it initialize map, to store matching bracket, corresponding bracket, whatever you want to write. All okay. Now second step, what we're gonna do, and we have seen that when we see, and this is for closing bracket, we'll use map when we encounter a closing bracket, but when we encounter opening bracket, we decided to store it in stack. And the intuition behind using stack was like we want to keep track of all opening bracket, and when we see a closing bracket we want to process most recent inserted value, which is the top value. So in that case stack is the best candidate to use. So that is why initialize stack to keep track of open bracket. So I will get a stack of integer, let's call it as st, and new stack, and it's done. Now I will iterate through the string. For int I equal to 0, I less than as dot length. This is how, and this is not an array, so we have to keep in mind in string length is a method, so we have to give this open close bracket. So yeah, I know it's really basic, you already know it. Yeah, so this is how. Now we'll get the character at each index. So here I will character c equal to s dot char at I. So we got the character. So here we might have two conditions. It can be a closing bracket, it can be an opening bracket. And if it is a closing bracket, we need to look into a map. And if it is a closing bracket, it will be, the key will be in our map, because there is only two possibilities. There is only three possibilities of having close bracket. This. So let's see if it is if the character is in map, means it is if character is key in a map, we can say that it is a closing bracket. If it is not there, we can say that it's a opening bracket. Right, this is how we'll decide it is closing or opening. You might be wondering earlier, like how we will decide which is closing and opening. So this is how. So here we'll go ahead and check if hm or hash map hm dot contains key. You can watch it in 1.5x. I know I'm going really slow while coding, so you can see that. So if hm dot contains key, in that case I'll go and do the processing. Like if it contains key, I will match it with values and check that if top of this text is that, then we are going to do return false. So I will again come to it right now, right? Else, what if it is opening bracket, right? So in that case, we are not going to do anything. We are just going to push it into the stack, st dot push c, right? So we have done the else part. Now in if part, we will check if our stack is empty. If it contains, we have a closing bracket, but our stack is empty, we didn't have anything as opening bracket. In that case, if st dot is empty, so in that kind of case, if it is empty, so we have to do what? We have to return false. What this means is empty, it means that we have a closing bracket, but we didn't have corresponding opening bracket for it. Hopefully you got it. Now I'll write one or condition. What is one more condition to return false? Like we have a in a map, in stack, we have at top of the stack we have different bracket. So in that case also we have to return false, and that case will be like this. Suppose we have in our stack we have this bracket, and we found these are not matching, so we have to return false for this. So that is the other case. So we'll stack dot pop, and if it is not equal to hm dot get will give us the value. So if this is the case, then also return false. And now at last, suppose our stack has some value and we iterate completely. So this is the case. Suppose our stack has some value. In this case, our stack will have everything will get popped, but our stack will have this value, and we completed the iteration. So in that kind of case, this is not, this got cancelled, this got cancelled, this got cancelled, but it remains same. So in that case also we have to return false. And how we will check that? We have checked all possibilities of false, and there is one more possibilities of false. So that will be that we'll check by doing return st dot is empty. It basically means we have checked like we have popped everything in element. If we have popped everything in element, means everything is balanced and all well on and good, so we have to return true. So now I will try to run it. So the step 1 is to this and iterate through. Step 3 is iterate through the string and find out the possibilities of having open bracket, close bracket, and process it as we have discussed here. So I will run it. There is some problem. Stack.pop not equal to hm.getC integer and character. So where I have declared shit, sorry, character. Hopefully everything is cool now. Yeah, all test case pass, submit. So yeah, our solution got accepted. So thank you guys.